Okay, so today we're going to look at the project, and I'm going to go into a little more detail than I normally do. I think the 2:30 class took about a half hour. So essentially what we have going on here, how many of you are familiar with the Mega Ball lottery game? So I came up with this idea a couple years ago when it hit $1 billion for the first time. It's done, I think, 2 other times since then. So what we're going to look at is we're going to use what we learned in the probability chapter, dealing with combinations, dealing with expected value. And we're going to calculate the expected value of a Mega Ball ticket. Now, there are some things we have to do to have this work. First of all, I chose Mega Ball because all but the grand prize is the same no matter what. So there's no adjustment for how much money is spent on tickets. Only the grand prize changes based on that. So back then, the original grand prize for if it got won the previous drawing was $40 million. So that's where the $40 million comes from for the prize. And then all the other prizes are set. They're always that amount, which makes it easier to do an expected value. Now, if you remember, expected value is you take the winnings or losses for each outcome times the probability, and then you add that up. So I've set this up as a table. Okay, I got you. So looking at our table here, we have the possible outcomes. Then we have the probability as given to me through the lottery. I looked it up on the lottery website. Then we have the prize amounts. And again, all these prizes from here down are always the same. And we're assuming the prize is at 40 million at the beginning. So next we need to calculate a net gain or loss. Ticket is $2. So if the prize is 40 million and we paid $2 to get the ticket, our net gain $39,999,998. Right? And then I tell you what to do, take the probability times the net. So we would have 3,999,998 over 302,575,350. Now, one of the first issues that I've had with this, and I say this every time, don't divide yet. Leave it as a fraction. If you divide, you're going to end up rounding, and it's going to throw things off a bit. Probably not a whole much if depending on where you divide or where you round, but still. And then we're going to do that for all of these. And calculate the next gain. Note here, this one's 0. And more importantly, this one is -2. So then we're going to take the net gain and multiply it by the probability and get all of these. And this one's going to be negative. Then you're going to take all these figures here and add them up. And you're going to get some negative number. I don't know what it is. I don't recall. Over this $302,575,350. So it's going to be a negative number. And when you do the division, I can tell you the answer is going to be negative $1.67. Which what this means is if you were to buy all 302 million lottery tickets or Mega Ball tickets, you would lose $1.67 out of every $2. So you'd only get 1/6 of your money back, even guaranteeing you winning the prize, the grand prize. So that's the first thing I want you to do. Now, the second thing I want you to do is calculate the break-even point. So I need to know what number here or what number here counterbalances all these to give me 0. So again, we just take all of these and add them up, and if memory serves me correct, it is roughly negative 546 million. So in order for this to be 0, I need this to be the positive version of that. So that's what the price would have to be for it to be even, break even. Which basically means, mathematically speaking, the only time to play the lottery or the mega ball is when the prize is over $546 million, which it currently is actually. Any questions on how this works? That's all I need you to do. So what? This part is easy. Subtract 2 from this for all of them. This part's easy. Take what you get here and multiply by what I have here, leaving it as a fraction, add it all up, then divide. That's your expected value. Then don't add the top one. And then whatever you get as a numerator is what the price has to be to break even. But it'll be positive instead of negative. Any questions on that? Now, there is a brief recording similar to what I just said that's already in Canvas. And then I'll post today's recording as well, for those of you that aren't here right now. But what I wanted to go into, because I noticed something when I decided to do this. These probabilities, I got these from the lottery website. And some of them are wrong. So what I wanted to do is go through calculating the probabilities. Okay? So the first thing we have to keep in mind is we're going to choose, I did that last time too. 5. We're going to choose 5 of 70 numbers. And that's the 5 numbers in the body, and we're going to choose 1 of 25 numbers. That's the mega ball. So now, our first prize here is winning it all, having 5 of 5 and 1 of 1. Well, how many ways can I get all 5 numbers? Only one way, right? Order doesn't matter. Right? So that's one way. How many ways can I get 1 number? One way. So this means there's only one way to get this. So my probability, and let's go ahead and say 5 and 1, is simply 1 over 302 million. Oh, I lost the number. Oh, we don't know that yet. That's why I lost the number. 575,350. 575,350. I skipped a step. We didn't calculate the denominator. Now, how many ways can I take 5 of 70? That's 70 factorial over 70 minus 5 factorial, 5 factorial. 70 times 69 times 68 times 67 times 66 times 65 factorial over 65 factorial times 5 times 4 times 3 times 2 times 1. These cancel out. 5 factorial is 120. 70 times 69 times 68 times 67 times 66 gives me this. We do the division, and I get this 0.3014. And then there's, of course, 25 balls, so there's 25 ways to pick the Powerball. So we multiply that by, go away. Multiply that by 25. And we get our 302,575,350. So that's where that number comes from. That's the total number of tickets there are. So we have our first probability tier. And that does match. Now our next prize tier is getting 5 of 5, and we've already determined there's one way to do that. And 0 of 1. So there's 25 possible numbers for the Mega Ball. One of them is the winning number. So how many possible ways can I get the non-winning number? $25 numbers. One's a winner. How many of them are not winners? 24. So multiplying this together and I get 24. So this is fairly easy still. 5 of 5 and 0 of 1. 24 over 302,575,350. And that one matches as well. Next, we have 4 of 5. Dang it. 4 of 5 and 1 of 1. Well, 1 of 1 is just one way, right? You already determined that. 4 of 5. So I have 5 numbers and I'm getting 4 of them. 5 factorial over 5 minus 4 factorial 4 factorial. 5 factorial over 1 factorial, which is just 1. And 4 factorial. So I have 5 times 4 factorial over 4 factorial, which is 5. However, that's only, I can get 4 of the 5 winning numbers 5 different ways. What about the 5th number? How many ways can I get that? How many non-winning numbers are there in this body of the ticket? Well, there's a total of 70 of them. And 5 of them are winning numbers. So how many are non-winning numbers? Non-winning numbers, 65. So 65 ways to get that non-winning number. 5 ways to get 4 or 5. And I believe that is 325. So again, 325 ways to do this. Multiply. And we have our probability of 4 and 1 is 325 over 302,575,350. Is this making sense? We're just doing the combination stuff. Thank you. So my next prize tier is 4 of 5 and 0 of 1. Well, this works out nice because we already know these. How many ways can I get 4 of 5? Right here, isn't it? How many ways can I get 0 of 1? It's right here. So I simply multiply 325 times 24. And I get 7,800. So my probability of 4 and 0, simply 7,800 over 302,575,350. Okay. Right on this. So our next prize tier is 3 of 5 and 1 of 1. And we know 1 of 1, there's only one way to do it. Now, 3 of 5. So I have 5 and I'm choosing 3. 5 factorial. 5 minus 3 factorial. 3 factorial. So I have 5 times 4 times 3 factorial over 2 factorial, 3 factorial. I get 20 over 2, which is 10. Now, how many ways can I get 2 non-winning numbers out of the 65 non-winning numbers? So that's the same setup. Not too difficult. 65 factorial over 65 minus 2 factorial, 2 factorial. 65 times 64 times 63 factorial. 63 factorial and 2 times 1. So these cancel. We have 65 times 64 equals 4,160 over 2, which is 2,080. So I take this times this. I get 2,000 or 20,800. Multiply it by 1, and I get 20,800 over 302,575,350. That's the probability of 3 and 1. Still with me? So the next prize tier would, of course, be 3 of 5 and 0 of 1. And we know both of these already. 3 of 5 is 20,800. And 0 of 1 was 24. So we simply multiply. So I get 20,800 times 24. And I think this is the first one that's not correct. I think the one on the list is 300 instead of 200. So my probability of 3 and 0 is 499,200 over 302,575,350. For the project, let's use the numbers that are actually in the project. Don't worry about these numbers. What I'm doing is showing you how these numbers would come about. And the fact that the state of Florida messed up. Because I believe everyone from here on is wrong. not by a whole lot, but just a little bit. Next prize amount is 2 of 5 and 1 of 1. And of course, we know there's one way to do that. Now we have 5 and we're choosing 2. So I have 5 factorial over 5 minus 2 factorial, 2 factorial, 5, 3, 2, which we had right here. Right? So save ourselves some thinking and just put 10 because that's what it is. Now I'm picking 3 losing numbers out of 65. And there's 65, choose 3. 65 factorial. We're in the home stretch. 65 minus 3 factorial. 3 factorial. 65 times 64 times 63 factorial. Nope, I need one more, don't I? 63 times 62 factorial over 62 factorial times 3 times 2 times 1. And I end up with 65 times 64 times 63. Which is 262080 over 6. And notice all these numbers are coming out even. Any combination or permutation problem, you should come out with an even number. So now I'm taking this times this, which is 436,800, then multiplying it by 1. And my probability of 2 and 1 is 436,800 over 302,575,350. The next prize tier is 1 of 5 and 1 of 1. And we know there's one way to do that. How many ways do we get 1 of 5? 5, choose 1. 5 factorial over 5 minus 1 factorial. 1 factorial, and of course 1 factorial is just 1. Interesting side note, 0 factorial is also 1. So this is 5 times 4 factorial over 4 factorial. This is 5 again. Now I have to pick 4 losing numbers out of 65. I'm looking at 65, choose 4. 65 factorial. 65 minus 4 factorial. 4 factorial. 65 times 64 times 63 times 62 times 61 factorial. 61 factorial times 4 times 3 times 2 times 1. I know that's 24. So I have 65 times 64 times 63 times 62. 1624890. Dividing by 24, 677040. Now I multiply that by 5. And I get my calculator died. There it is. Nope, now it's gone again. That's interesting. Come on. This is a brand new calculator. 3385200. Multiplying that by 1. So my probability of 1 and 1 is simply 3385200 over 302,575,350. Last prize tier. Zero of five. So 5, choose 0. 5 factorial over 5 minus 0 factorial, 0 factorial. Remember we said 0 factorial was 1 by definition. So I simply have 5 factorial over 5 factorial, which is 1. There's only one way I can get 0 of 5, get none of them. However, need to take into account the number of ways I can get 5 out of the 65 non-winners. 65 factorial. 65 minus 5 factorial times 5 factorial. 65, 64, 63, 62, 61, and 60 factorial. 60 factorial times 5 times 4 times 3 times 2 times 1. Okay. These cancel out. And I forgot to do something in the previous class. Shame on me. Times 63 times 62 times 61 equals a whole bunch. 991186560. This is 120. And I get 8259888 times 1, so 8259888 times 1 again, so I have probability of 0 and 1 equals 8259888 302 575350. So that's all the winning combination. What did we forget? Anybody? We need one more thing, don't we? Losing combinations. Very good, Addison. Now, we can do this two ways. We can do some more combinations, or we can cheat. We can add up our winning combinations. 1 plus 24 plus 325 plus 7,800 plus 20,800 plus 499,200 plus 436,800 plus 3385200 plus 8259888. So that gives me 126,100,38. That's the number of winning combinations. So to calculate losing combinations, we can simply take 302,575,350 Subtract 12, 610,038. And we get 289,965,312. So probability of losing is 289,965,312 over 302,575,350. So your probability of losing, just for fun, 302,575,350 is 0.958324305. So you have roughly a 96% chance that you're going to lose a lottery and not win anything. Any questions? Like I said, you don't have to go through all this. All I want from you is filling in the rest of the table and calculating the two values. The actual expected value, which with those numbers comes to be about negative $1.67, and the value you need for it to break even, which is somewhere around 546 million. And I believe the prize is 638 million right now. So mathematically speaking, it would be worth it to play. The only caveat to all this is we're assuming that you're the only person that wins the grand prize. Now, in this particular game, if more than one person wins it, it's split between them. So that would throw everything off. The best case scenario. Now, on the lower prizes, it doesn't matter if other people win them, because that's set amounts. But that's where these numbers come from on that table, or where they should have came from. I guess I'll change it next semester. That's what I get for trusting the lottery.